Hello, I'm Huiling and I'm doing my PhD in the Aeronautics department. I'm also a fellow of the Software Sustainability Institute. This is my elevator pitch on why version control is important for research reproducibility, how it can improve your productivity, and is a hitchhiker's guide to Git for researchers. Anyone that has ever had to create a presentation or report is intimately familiar with a folder that looks like this. You start out fairly confident of which version you are at, and as the deadline looms and as you think you're done, the file names get more and more desperate. This system works, but where's the quality of life? It gets painful after a while, and there are some features that are nice to have. For example, wouldn't it be nice to have a descriptive message with each file version to know what exactly that version is? Or to have a timeline view of the different versions with these messages to know what is in each file and how it has changed over time? Lastly, to be able to see what has changed between the versions. This is not as important for a Word document, but for code, it would provide the insight as to why the program is behaving differently. For a Word document, this system of naming files differently between versions kind of works, but if we now have a Python project with more than one file, then the complexity increases significantly. The solution to this problem is version control. Software engineers came across this problem and built tools to automate it. Such tools are called version control software, as they control, organize, and track different versions of files. A key feature of it is that it allows you to recall specific versions later. Git, SVN, and Mercurial are all examples of such software. Git is the most popular version control system as it is free, simple, fast, and allows for distributed development. There are several providers which can host your code, sort of like a cloud provider like OneDrive, but for code specifically. GitHub is the provider that I'll be focusing on for this talk, as the college has an organization on it and it provides access to paid features. For PIs, teams can be created within the GitHub organization with the visibility of the team and the repository set accordingly. Having your code in a remote repository on GitHub is an excellent way to back up your code. And for those of you who are worried about other people viewing your code, fear not, as it can be made private. Normally, when people talk about Git and the benefits of it, the focus is on how it's a powerful tool for collaboration. However, I want to show how an individual using Git without collaborating with anyone else can derive significant benefits, how this tool can make your research reproducible and transparent while improving your productivity and quality of life. In this talk, I will show how easy it is to put any existing code on GitHub, an overview of the workflow for continuously updating it, and useful project management features on GitHub itself. This is a demo of how you can back up all your existing code onto GitHub itself. The first step is to create a directory. I'm now going to move into that directory. In that directory, I'm going to create a file called readme.md. In this file, I'm going to put in a header called Git for researchers. Now, this file represents all your existing source code that you now want to back up onto GitHub. The next step is to create a repository on GitHub itself. I'm going to call it Git for researchers, but there is no need for this name of your repository to match the name of the folder that you created. Then I'm going to specify the visibility of my repository as private, as I don't want other people looking at my repository yet. GitHub will then show me two sets of instructions. The first set of instructions are for creating a new repository. As I do not currently have one, I'm going to follow that set of instructions. The first command in that set of instructions is git init. What that does is that it initializes a new Git repository locally. So this is where my code is at the moment, and I'm going to create a local Git repository there. The next step is to call git add for all of my existing code. Since all of my existing code is just readme.md, I will just add readme.md. Once that's done, I'm going to commit these changes and put a message. In this message, I'm just going to say first commit, as there is no additional information that I need to add other than saying that this is the first ever commit I am making. The next step is then to tell my local repository that my main branch will be called master. With that, I will then tell my local repository where the remote repository is. With that, I'll push all of my changes to my remote repository, and now when I refresh the page on GitHub itself, you'll see that it has a readme.md file and the heading Git for researchers. There are only 3 commands that you need to know to keep your code up to date: add, commit, and push. Let's start at the working directory. You've made some changes to your files and you've reached a new working version of your code and you want to back it up onto GitHub. First, you need to git add your changes. This places them in the staging area, which means they are ready and in place to be committed into your local repository. Once the changes are committed, they can now be pushed to GitHub. As you make more commits, it eventually develops into a timeline. With good commits, it becomes the so-called story of your code. When it comes to reproducing results from, say, 5 years ago, Git allows you to go to that exact version. If there is a bug, this view of a file provides a form of annotation to each line of the code, which allows you to pinpoint when exactly a bug was introduced and if it affects the results. These 3 commands don't even tap into the full potential of Git. However, it achieves the goal of having a backup of our code whereby we're able to access past versions that have messages attached to each version such that the evolution can be viewed. It's also possible to add tags such that a given snapshot can be labeled and, say, related to a given paper. Git may seem very foreign, but if you've ever used Overleaf, you've actually indirectly used Git. One of the very useful features in Overleaf is viewing the history. Here you can see that there is a similar view that we saw in the previous slide, where you can see what the change was and who made it. Overleaf also comes with a very useful feature of labels. These labels use the git tag feature, which lets you give a tag, or in this case label, to a specific commit. Here, I've labeled the commit I made as version 0.1. When going to the labels view in the tab on Overleaf, you'll see this newly created label. This allows you to have named versions like our traditional file naming system without Git. Conveniently, GitHub comes with some extra frills that makes it a powerful tool for project management. One of the features is projects. A project is an adaptable spreadsheet, task board, and roadmap that integrates with your issues and pull requests on GitHub to help you plan and track your work effectively. This helps with the ongoing development and becomes a form of documentation. Moreover, this can ease the onboarding of new people onto a project and allow them to hit the ground running. Pull requests can be used in isolation or with GitHub projects. Regardless, they are a useful tool for demarcating a set of changes to a feature or a fix in this example. Here, we have a title which relates what Python version this change is for, the unique identifier for the piece of work, and what the changes are for. There is then a brief description of the fix, followed by which issue it relates to. All this becomes a form of living documentation. More often than not, I read code that I have written and wonder, why in the world did I do that? When I worked on the OpenJDK, the existing pull requests and commit messages were vital to understanding undocumented parts of the language, the rationale behind its implementation, and what features or security fix it related to. Ultimately, it gave me a way into figuring out what in the world is going on. Alternatively, if you have a personal vendetta against X, previously known as Twitter, and want to mess around with their devs, you could submit a pull request to replace the entirety of the recommendation algorithm source code with the video game Doom. This pull request was closed, which means that the source code wasn't replaced. Although it is open source, the access controls on a given repository give the owners the ability to specify permissions and safeguard against such actions. So, why should you make your code public? This is an example of a public repository that's on the college's GitHub. As a self-taught programmer, I am always very self-conscious about the code that I write, and I don't want people reading the spaghetti code that I've written and judging me for it. However, in research, there is the added benefit of making the effort used to create that software recognized. Through Zenodo, a DOI can be associated with your code, and this makes your code citable and for other users of your code to credit your work. By having a public repository and making your code citable, it allows for the traditionally unrecognized research output to gain recognition. It also makes it possible for your research to be reproduced and potentially adopted. This is the first talk in my Git for Researchers series. Each is a 15-minute introduction to using Git in ways that genuinely support your research. Rather than being a simple list of commands, it offers a high-level perspective on how to apply Git's features meaningfully, so you're not just using it for the sake of it. I'll show that it's much easier than it seems and share received wisdom handed down from master software engineer to apprentice on using Git as a tool and skill for improving your productivity and quality of research. For example, the third talk on commit messages is about how to write good, useful commit messages that can assist in the understanding of the codebase and for debugging. To summarize, why should you use Git? Why care about documentation? For me, it's about taking the time now to make future Huiling's life easier. Past me is my most frequent and infuriating collaborator. They are completely unresponsive to emails, and they often do questionable things that makes me want to strangle them. Version control and documentation becomes a form of communication between past you and future you. It's an investment into making your life easier. Because life is hard enough. The science is hard enough. So let's make the software easier. Thank you, and I hope you enjoyed my presentation.